Hello everyone, today we're going to be studying Thevenin's theorem for DC circuit analysis. So, what does it state? Thevenin's theorem states that it is possible to simplify any linear circuit, irrespective of how complex it is, to an equivalent circuit with a single voltage source and a series resistance. I'll explain it using the circuit diagram I have created over here. Our goal will be to find current response IL across this 1 ohm resistor RL using Thevenin's theorem. So according to the statement, we can write this diagram, we can redraw the circuit diagram like so, where we have a voltage called VTH, which is Thevenin's voltage, in series with a resistance called RTH, which is Thevenin's resistance, which is in series with our RL. If we can simplify this big circuit into this simple circuit, it'll be much more easier to find IL. So how do we do that? First, we need to find VTH. In order to find VTH, we need to remove RL and place a open circuit where RL is. Let's name this point as A and this point of the circuit as B. So over we remove this RL and we place an open circuit over here. After removing RL, we need to find the voltage across A and B. That will give us our VTH. So the voltage at this point A, let's say VA, it will be equal to the voltage at this point over here. Let's take V. So VA is equals to V. The voltage over here at this point just below the 5 ohm resistor will be 0 volts. And since this will be 0 volt, the voltage at point B, let's take VB, will also be equal to 0 volt. So in order to find the VTH, we need to find this voltage V. We can do it using nodal analysis. So using nodal analysis, this current I1 is entering V, point V, and two currents are leaving. Let's take this as I3 and this as I2. I2 will be flowing directly into the 5 ohm resistor. It won't go here to the 9 ohm resistor because there's an open circuit over here. And if there's an open circuit over here, it means that current won't flow through the 9 ohm resistor. So this I2 will directly go into the 5 ohm resistor. By Kirchhoff's current law, V divided by 5 plus V minus 50 by 4, because at this point the voltage is 50, so we need to subtract that from this V voltage, is equal to 3 ampere. Why? Because 3 ampere is leaving and I3 and I2 are leaving. So if we simplify this equation, we can take V common. V into 1 by 5 plus 1 by 4 is equals to 3 plus 50 by 4. So if we solve it further, we'll get V into 9 divided by 20 is equals to, let's take this as 3 by 1. This will become 62 divided by 4. So then V would equal 62 divided by 4 into 20 divided by 9. 4 and 20 will cross off. This will be 5. And then the resulting answer, you will get it as 34.4 volts. So this is our VTH. I will go up and write it over here. VTH. Too close. VTH is equals to 34.4 volts. Now we need to find RTH. To find RTH, we need to remove this 50 volt source and this 3 ampere source and replace it with an open circuit and a short circuit. So we're going to have to redraw this circuit diagram. We'll just have to erase this and this whole calculation. So we're going to have to draw it like this. This is point A, this is point B, this is the 9 ohm resistor, this is the 5 ohm resistor, this is the 4 ohm resistor. As you can see over here where the voltage was, we placed a short circuit, and over here where the current source was, we placed an open circuit. So now we need to find the equivalent resistance Req of this circuit, and that will be equal to RTH. So in the circuit we can see 4 and 5 ohm resistors are parallel. So we can find the equivalent resistance of these two resistors. R1 will be equal to 4 into 5 divided by 4 plus 5, which would equal 20 divided by 9, which would equal 2.2 ohms. And this 2.2 ohm resistor is in series with this 9 ohm resistor. So our EQ will become 2.2 plus 9, which would equal 11.2 ohms. Now we figured out the value of RTH, which is 11.2, and VTH as well. So now we need to construct that simplified equivalent circuit. I'll just erase all this. Now we can construct the simplified circuit like so. This is RL, which is 1 ohm if I remember correctly. This is RTH, which is 11.2 ohm. And this is VTH, 34.4 volts. Now we can easily find the current IL across RL. All we need to do is find the equivalent resistance of this circuit, Req, which would be equal to 11.2 plus 1 equal to 12.2 ohms. And then I is equals to V by R, which would be 34.4 divided by 12.2, which will equal 2.81 amperes. This will be the current that is flowing through this entire circuit. I. and that in this I value will be equal to IL, which is the current flowing through RL. So like this, we managed to find the value of IL, the current response across RL, by simplifying a big circuit into this very simple circuit. This is the value in Thevenin's theorem. Hope you found this video useful. Bye bye.